Hey, everybody.
Hello.
Where are you, Leonard?
I'm right in front of the coffee stand here, over in the press area.
That's not what I care.
NVIDIA GTC. You see that?
AI coffee.
Why do they call it GTC?
It's the
GPU Technology Conference. Yes.
It's not. Is it NVIDIA's own conference, or do they have all their partners?
Mm-hmm.
They bring partners, they bring partners, right? Because they have demos as well and joint presentations.
Yeah. Well, the running joke is they bring their partners and they don't talk about them.
Oh, they do. I've been listening.
No, they did. That's one of the big complaints.
I saw a lot of press announcements, but I haven't been watching, so I haven't been.
They bring their customers, not their partners. The people that buy their stuff.
That's fine.
2 days.
Yeah, but they call them partners, right? Because they integrate things together.
Yeah. No, Jensen mentioned all the partners when he was on stage a couple of days ago doing this thing. It was all good. Yeah.
That's weird. And that's an interesting question I've been asking a lot of people. I mean, who's your customer and who's your partner? And man, you want to talk about people going, maybe that's a good question. It's like, how do you not know that answer? Everyone thinks that they're a partner. They don't think, no one thinks that they're a customer. It's like weird.
Yeah.
Well, that's an excellent question in general, right? In all the industry.
Right.
It has become
what the hell are you? Yeah.
Wow.
Where do you fit?
The definition is pretty simple. I mean, you have a partner if you have a common customer that pay both of you. If the payment is one direction, it's not a partnership.
That's so
simple as that.
It should bother a lot of people. But hey, everyone, welcome to IoT Coffee Talk. We still have coffee talkers strolling in, but full disclosure. Take us seriously at your own friggin' risk, okay? Do not gamble, bet on the stock market and anything else, forces, based on anything that we say, okay? We're just here to have fun, and we hope you enjoy the show.
What about the bracket?
So I'm risking this because last year I made a big statement, and of course we went out in the first round to a number 16 seed. So if it happens again, I'm a jinx. So.
Well, my Aggies play on Friday, and I just have no idea because they've been so up and down this year. So,
well, Stephanie, you know who I'm pulling for. I'm pulling for Phi Slamma Jamma, University of Houston Cougar.
You know what? Once the Aggies are out, I'm all in for Houston.
Even without Clyde Drexler or Akeem Olajuwon, they're going to get it done this year. They got really close last year. They're going to get it done this year.
You think?
I think they are. I think Houston's good.
This year we have a strong Auburn playing.
Auburn looks good. Yep.
Yeah.
Auburn looks good. That's my team.
I've got them in Final Four.
Friday.
I shouldn't disclose that. I run an NCAA pool, and there's a lot of people in it. So I don't have Auburn in the final.
My son didn't get into their aviation program, so I'm like a little bit bitter about that. So I'm like, screw Auburn.
Oh, really? He tried to get into their aviation program.
It's very, very competitive to get into their aviation.
It is. We toured it last year. Our son is a double student at Auburn. Yep. And we go several times a year. And when we go during Parents' Weekend, we tour various engineering schools.
That's good.
And last year we did aviation. We've done nuclear engineering lab, mechanical engineering. We did that. That's huge. But awesome. Aviation, yeah, you're right. And it was quite interesting. And there was a female student that gave us the tour. So it was very refreshing because she said her grandparents, she was from Huntsville, her grandparents had worked for NASA.
Oh, nice.
Grandparents.
Yeah, I've got a friend. I got a friend at Purdue that's a NASA astronaut. He was my pledge, a guy named Drew Feustel. Great guy.
Oh, that's remarkable.
Purdue has a pretty reputable program as well. Yes.
Yep.
Yeah.
Much more impressive than I am, but a guy that's been in space with a wrench fixing the Hubble.
You know.
So you went to Purdue, Eric?
I did.
Oh,
I was
congratulations.
trying to figure out what Purdue wants to be. On the one hand, I hear about all the ISA 95, the Purdue model for IoT, blah, blah, blah stuff. And there's a lot of people who live and breathe that. Then I also hear, when I spent all that fun time in agriculture, Purdue is also
Big ag.
the big ag school, and some of the biggest thought leading in agriculture comes out of Purdue as well. So it's kind of a 1-2 punch, whether you're on the factory or the farm.
Yeah, it's that you just described Purdue perfectly. I mean, spending 4 years there, it was really a lot of engineering, obviously, and aerospace and ag. And the computer science, I'll age myself. It was pretty new when I was there. And we weren't really, in fact, it was in liberal arts when I started, and then they moved it into the School of Science. So, but it's become pretty good at computer science.
So are you a mechanical engineering grad?
No, I was a pure computer science.
Oh, you are? Okay.
Yeah, all VAX, the VI editor, terminal guy stuff back in the day.
Outstanding.
Hey, I communicated when my husband and I started dating. We were communicating on VAX machines.
Yep.
I
started out on a DEC PDP-11.
I was a student. He was working at TI, but we were on VAX machines. So we're not the only one there.
So the VAX machine was kind of like your Tinder or whatever back then.
Well, it was
Swipe left or right.
When you think about the history of computing, think about the PDP-11. If you remember, Steve Wozniak was trying to recreate the PDP-11 on a piece of plywood when he built the Apple I.
Yep.
And that's and he's like, well, we don't need this, and we can make this smaller, and and kind of blew apart the notion that these machines had to be giant.
He was one of my heroes. Him and a guy named Richard Garriott, if you know who Richard Garriott is, the gaming guy from Ultima.
Oh yeah, Ultima. I remember that game.
He's an Austin dude. Yeah.
Okay. All right.
So I was that kid. I was that nerd in the computer science center that spent a lot of time playing Dungeons and Dragons and doing computers and very, very, very little time with girls or dates. It was all computers.
Yeah. That was
not shocking, I'm sure.
What a nerd.
You're
complete nerd.
I know last night my son had he was preparing for a math test. And he always gives me the complete study guide. And he goes, Mom, here, fill this out so I can study it. And I'm like, and I do because I love it. And I'm like, I'm such a nerd. I'm ready for and so I sent a note to all the parents last night. I said, I'm ready for the math test.
Oh my God.
You can touch that stuff nowadays.
By the way, do you remember the name of the app you were using to chatting on the VAX?
Oh gosh, no.
The app was called Phone.
Oh my God.
Because you were phoning between one terminal to another using VAX VMS. And I wrote the similar app on the mainframe computer to do the same kind of stuff.
Oh, nice. Cool. So you're also a nerd, Dimitri. Welcome.
History.
Oh, yeah.
Yeah, well.
He's a nerdy historian.
I don't know.
Look at the background of Dimitri. Look what's kind of there.
I might have told the story on the show, but one of my first hack was on this IBM 360 French equivalent, and the thing that the source code of the operating system was somewhere hidden in the computer, so you could change the operating system, crash it, and reboot it. We did a few stupid things. The thing we didn't know at the time with my friend that computer was used to compute the result of the engineer schools in France nationwide.
Oh wow!
So when they realized that we were hacking the thing, actually we told them, they got pretty scared.
Yeah.
Wow. Oh my God!
Yeah, I did the same thing at my dad's insurance company as an intern. I changed the messages and made them something stupid and got in a lot of trouble for that. It was the main thing.
That's awesome. So I made it to Texas. I'm in Dallas now, and I'll be in Houston next week. I'm running a conference. It's an oil and gas emissions conference, basically. It's these folks I've been involved with it for years.
How are you doing?
It's kind of like this energy conferences deal. For years they've done this kind of IoT oil and gas.
Oh yeah, no, because
and Leonard is so loud. But yeah, anyway, so that should be interesting. So I'm going to be the conference chair and run that thing for 3 days. So
what's it called?
It's a strange name. This one is called. It's like literally carbon tracking and reporting. It's And so last year, basically you'll have, VPs for sustainability or whatever from all the super major oil companies will be there. As obviously there's some stuff they have to do for the EPA. You've probably heard of the stuff that the SEC is requiring and all that kind of stuff. And it's a real thing that no one thinks about. But to tell you the IoT opportunity there, because I'd go there, before I was doing what I'm working on right now, I built that greenhouse thing just to track emissions.
Yeah.
We're not talking rocket science. We're just talking the importance of continuous monitoring.
Yes, completely agree.
And I'll give you the scenario, and then you can understand that even without ML or anything magical, there's so much value. Imagine if you're a small oil company and you have 400 drilling pad sites, let's just say around West Texas. And the government requirements are that you need to visit each one of those sites 4 times a year and take like a methane reading and maybe some other noxious gas readings. And then you have to get that data to them. How I always joke about, you're competing with a guy with a clipboard. Well, it's kind of like that. It's a guy in a pickup truck and a cowboy hat, and he does that. What the real light bulb for me, when I was actually talking to a guy who worked for a company, and he was explaining what he had to do, and he goes, "Guess how much that costs us? $35 million a year. It's a tax. It just hits us. There's no upside. We just have to do it."
Yep.
And I'm just like, it just seems insane to me. I mean, the simplest thing we did with IoT before you do anything fancy is just remote monitoring.
Remote monitoring, limit truck rolls, right? Same thing in rail. Truck rolls to inspect crossings. Reduce that workload. That look what happened during the pandemic, right? They didn't have people to go do this, and so it helped accelerate things.
One of the earlier use cases, and before I was even we were talking about machine learning, was the electronic meter reading and how it went from people to cars driving by and connecting, and then monitoring. But it was just like, I remember like laughing at the fact that they had the truck rolls, the trucks coming by to read.
People should realize how valuable it is to just, I know it doesn't sound sexy to produce truck rolls because it doesn't refer to a deep neural network, but it's mega valuable and it saves you money. The fact that this one company, $35 million a year, basically truck rolls is what it is.
Why? But so because I ask myself the same question. Sometimes late at night I watch stupid show like Gold Rush, and you look at how those people extract gold, and they have all this problem of a machine failing. I'm like, why don't they put a sensor in a camera? It's going to cost nothing. So the question is why? Why people don't realize that this technology is so easily available for simple thing, as you said, monitoring and just your kind of alert that your thing is vibrating far too much that it should go have a look at your thing.
Fear of failure.
So why isn't spreading?
Well, it's the physical aspect of that, right? Like we find the software part easy, but man, when you got to screw something in and you got to go out to West Texas and deal with spiders and just the environment, that's the stuff that's tricky. It's whenever
Speaking of West Texas, my husband's out in West Texas right now, and what he's doing, he's retrofitting all of the cameras that are pointing to all the feeders. So he already set up a monitoring system for all the tanks out there for water reasons, because if a water tank goes, then there's dead animals. But right now he's retrofitting all the cameras, because the old camera system, he would literally have to go pull the cards, through visually thousands of pictures to look for mountain lions and do all kinds of things, right? And now he's putting some smart cameras in, and he has to retrofit them because of the environment and all of this. And I'm like, babe, AI could go through all those
some edge AI,
and just find what you're looking for, because he's like, my eyes are burning. And that's what his practice has been for the past 7 years, is looking through thousands of photos. And I'm like, it's asinine.
Mountain lion, not mountain lion. Yeah. Rabbit, squirrel, tiger.
So maybe
show you something really cool.
There's a use case for kind of a ruggedized, pretty generic monitoring machine that you can deploy at scales. And then maybe there's a business to build there, because maybe those people just don't realize how kind of easy it is. The problem is scale, and it's very specialized. But if you can build something that kind of generic, with probably just a camera, a microphone, and a bunch of wires, and that is really rugged, hard, uses some kind of boundaries on the network somewhere. Yeah, well, maybe there's something to do that to help those people, because and maybe it is also we're doing bad by talking all about AI and ML and Gen AI, and so it still looks complicated, because at the end of the day, as Rob said, is level 1 is just monitor the stuff, and hey, there is something that shouldn't be here, which could be detected by vision, and go have a look. Already,
and this company Samsara is not fixing this. Do you know Samsara? Are they
doing it? They're doing it for free.
Samsara.
Yeah, I know Samsara. I'm impressed with Samsara. They've done a good job of. To me, they're one of the few IoT success stories right now. They really done a good job.
And they're not getting the notoriety that I think that they should. Like they're out there in the media. Yeah. They just aren't. They're kind of a quietly a successful company.
Quietly $1 billion recurring revenue a year. That's pretty good.
Billion.
Yeah. They nailed it.
They're at $1 billion.
Oh wow.
Yeah, they did really well. No doubt about it. But yes, I was lucky enough. My drive to Texas, I stopped in New Mexico and went to the Very Large Array. We saw the movie Contact.
Yes.
With Jodie Foster. I
Nice.
got to visit there and do the visitor tour, and that was so cool. That was so neat. Absolutely.
Did you see Jodie?
Inside the visitors building, there is like an audio kind of thing deal you could do, and it is Jodie Foster.
I love that movie. I love that movie.
I do too.
I have not seen
Matthew
it.
McConaughey, right? With Jodie.
Yeah, McConaughey. Yeah. Stephanie, you should watch it. It's just called Contact. It's amazing.
Yeah, I haven't watched it. But this is one of the things that amazed me about communication, how far away objects are sending data to our planet, right? What's the communication system that is out there in the space?
We are doing really small time IoT compared to those guys.
Absolutely.
Well, it's time travel, man.
It is.
And imagine the Voyagers ships, right? That they were around when in 70s, 80s.
Yes, 77, 76. Yes, I watched.
I read
documentary.
Yeah,
and I think we talked about that on the previous show. We're still reprogramming it, the Voyager.
Yeah, indeed. Yeah, and I don't know what language they use. I don't know if it's assembler or something.
It is assembler. Yeah, it is assembler for sure.
Because you're right, they did it in the 70s. When you think about, how something that's got to last that long, and they launched Voyager 1 in one direction and Voyager 2 in another, just for redundancy, hoping they'll survive. I literally just watched a documentary on it that's recent, as of 2023, and there's a small, tiny team now left who is still maintaining, and sending commands to Voyager. Yeah. I think they said it was 21 hours communication time because the speed of light is so slow.
Yeah.
And they're almost out of gas. They're almost dead. And it's really cool, but they're in interstellar space. They were able to totally map the heliosphere around the solar system because it penetrated it. So, because a lot of people, after it, it was going to do, Saturn, Jupiter, Uranus, Neptune. And then after that, mission was done. But it did die. They just kept going. And so lots of people left the team. And so there's this skeleton crew. You want to talk about the idea of having your important computer under your desk. Yeah. There's in their office, there are these computers and the big signs don't touch.
That old code lasts forever, right? Assembler, COBOL, it's again, that's my old world when, the stuff that's running air traffic control.
Think about how much shorter its life would have been if you'd written the code in one of today's bloated programming languages.
Yes.
It requires way more CPU cycles to do the same thing.
There would be no sustainability on that, Rob.
No, I mean, and I think it's actually a lost art.
It's beyond the languages that was used. There was a lot of documentation, the Apollo Guidance Computer. I watch a lot of shows. There's actually a great show. It's called Light Years Ahead. The guys that explain, but it's more than the language. It's really the design principle and the reliability and the tight integration between the hardware, the operating system, and the code, so that it's reliable. So it always restarts on its own feet. Yeah. It has things checkpoints. So it's kind of a very strong thinking and design. If you look at the way those things were designed in the 60s, this is beautiful. Now we just write a bunch of freaking Python and hope that somebody will catch the bugs during testing. So
I think the pendulum's moving back though. I think this whole world of cloud, and we've become I had an exec, I won't name the name, years ago, tell me that performance no longer matters because you have ubiquitous computing in the cloud. And my CTO is with me in this meeting. He's like, performance will always matter. And I think that you're going to see that pendulum swing back because as we go more to edge computing, that performance is critical as you scale up that stuff.
It absolutely is. And it also costs money. So when I was at Hitachi, we're doing the Lumada thing, and I would walk around with the engineers building the tech, and they thought I was insane. I was like, I need you server developers to think like embedded developers. And you need, and they did have that initial idea. Oh, it's the cloud, it's ubiquitous, we have unlimited, whatever. I go, this costs money, and that money gets passed on to the customer. Because you write worse bloated code, and we have to use a larger size virtual machine, for instance, in AWS, there's a cost to that. I go, a performance and efficiency matters. Pretend you're doing embedded development on a server.
Yes, because if you're going to get to millions and millions of concurrent devices, you have to have that performance. Yeah. It's got to be cost effective for these companies.
Absolutely. It's so important. No doubt about it. Wow. Yes. Well, that's cool. The water tanks, Stephanie. A good friend of mine, Jimmy Chapman, he's got a little company called Ranch Sense.
Well, Chris
I know Ranch Sense.
Yeah, he's in San Antonio.
Yes, I've talked with him.
Chris uses him for all the water tanks. So he's already a customer, and they do business together already. He talks to him more than I do.
Yeah. Gosh, when did I talk with him? 2020, I think. Yeah, I get introduced to him from someone else in the industry.
He used to work at WellAware.
That was it. It was the WellAware guys that introduced me to Jeremy. Yeah,
absolutely. Yeah, it's good stuff.
He follows us very closely too, so he'll probably listen to this.
Hi, Jeremy. Maybe you remember me. It's a long time.
You never know. Absolutely.
All right, I'll see you guys.
I got to run too. I got to Uber. I got to catch. Good to see you, folks.
Bye, guys.
See you later.
See you guys.
Yeah, absolutely. Good times.
How's NVIDIA GTC, Leonard?
Yeah, what's the hot topic, Leonard?
Am I the only one?
Tell us, Leonard.
More GPUs.
Blackwell?
No, it's just yeah. No, I mean it's you have to hand it to the guys at NVIDIA. They with the Blackwell chip as well as the new machines for the systems that they're offering. Man, they did a pretty good job of reducing the size and the power performance. Although one of the questions I wanted to ask Jensen, I was at the analyst Q&A, was like, well, what are you talking about in terms of like the energy consumption reduction? Is it at the data center level, or is it per rack or even by the rack? And so it's hard to tell. They put out these crazy numbers. I mean, everyone does it, right? You always have to try to figure out, okay, against what or assuming what, right? The context around the numbers. But irregardless, I mean, generation over generation, it's pretty massive improvement. And one of the interesting things is, they did that whole thing that Apple did. They took two dies and stitched them together with something kind of like Ultra Fusion. But that's a TSMC integration technology, right? But I think they probably use the same one, more advanced version than what Apple uses. Well, maybe not. Newer generation Apple Fusion, might use. They actually use the leading edge stuff. Because it's interesting, the new Blackwell GPU, it doesn't run on the leading edge node. It's M4, TSMC's M4. So, I mean, it's still really, it's just like one generation behind or a talk behind. But man, they're just like friggin' densifying these machines like crazy. And, taking these reference designs and then, trying to get their ecosystem to build this stuff out. On the software side, they're starting to move like they introduced a whole thing called NVIDIA. What is it? NIM. They call it NIM, but I forgot the
Metropolis? No.
Oh, the microservices.
There's the microservices.
Yeah, microservices. Yeah, NVIDIA.
It's on Metropolis.
Microservice.
But I don't.
No, it sits on CUDA.
But it didn't look there was anything innovative there. I mean, it's just the packaging of the service.
Yeah,
the way that it's deployed to their GPUs. But so it's just containers that run on.
It's basically like AI applets, right? So you have like little things that you can then plug and play into an application, a bigger application.
Yeah.
And so it makes these AI functions a little bit more composable, and maybe you can do like hybrid or fusion type functions with these, call them standalone and maybe application specific AI functions.
Mm-hmm.
And they might be based on their own little model. I mean, it's not really novel stuff, but they're doing it, and it kind of, I don't know. When he first started describing it, I was like, man, doesn't this like compete with some of the stuff that OpenAI is doing and some of these other dudes are doing, like Microsoft and Google, where they have similar kind of like, what do they call them? Chatlets or whatever the hell. They have some equivalents, right?
Yeah.
And so it makes you really wonder, okay, what's going on here? Because it's like these dudes are like sucking all the oxygen out of the room, right? And really, it makes you wonder, like, what's going to be left for everybody else? They're like a singularity, and in terms of disruption, man, they're like slapping everybody in the face, up, down, left, right. I mean, it's just like, okay. No boundaries. No boundaries. I felt like these guys are
one
doing.
of the big takeaways while you're saying, it's no big deal. I mean, that Blackwell, there's like something like 1,000x more performance versus Grace Hopper.
No. It's actually in terms.
He did mention that the overall performance has increased like 1,000x in 10 years. So it's over like
10 years.
So he said, by the way,
from 10 years,
it's better than the Moore law, but the Moore law was not about performance; it was about number of transistors. So,
but that's not even fair. It's just this is a different type of compute and a different type of curve.
Yeah,
you don't compare the two because actually they're still dependent on Moore's law. And so like when Jensen came in, what was one of the things? We're going beyond physics. It's like, no, not really. It's that was actually my point. The Moore law is about the number of transistors, so you don't compare about transistors and performance. This is kind of, make any sense? It's really architecture. It's architecture.
I have a quick question for you, Leonard, because the interesting thing, I kind of listened to the keynote a little bit, but one thing I was surprised that there was no real mention of improvement in terms of costs. So
because you were drinking shots. Yeah. So how much bingo?
I mean, whose cost are you talking about?
No, the cost. Well, it is.
I know.
Is this new chip twice, 3 times expensive or 2 times cheaper? Or or it doesn't matter.
Yeah.
VCs are gonna fund anyway. So
they didn't sell it anyway. They didn't provide a chip, but then it's probably not 2 times more expensive. I mean, the H100s are going to become cheaper, right? They'll probably tier it, but. There are definitely, certain some step changes in, the interconnect as well as, the chip itself, where, it could probably, creates a pro tier to a certain extent. So we'll see. I don't know what the pricing is like. They didn't talk about it. They wouldn't answer questions about it. So
I have a stupid question here. Mm-hmm. What's the role of ARM here on all of these NVIDIA game?
The Grace CPU processor. That's all.
So it's only
ARM-based.
CPU.
Only CPU. Yeah. As far as I know, they could be doing some weird stuff on the GPU, but I don't think they're gonna. No, the GPU is actually all NVIDIA. It's basically just the CPU and maybe some other things like microcontroller level stuff for all the edge stuff. But that's that's the thing. Those parts of their business are they're not all let's put it this way, they're not growing as astronomically as the generative AI compute side. And, the reason why I say that is I think about 80% of the revenue now is based on their generative AI supercomputing segment, right? Then they have like the normal AI stuff, the stuff that they had, pre-generative AI. I think that's still, I don't know how much more that's growing, but it's probably not that, it's probably not on the trajectory as the other generative AI stuff. But when you look at how many customers they have on 80%, probably 75 to 80% of the revenue is like 2 or 3 companies. You know what I'm saying?
Yeah.
And it's not end market stuff. Maybe Meta may be using it for infrastructure services, but definitely guys like Microsoft and other hyperscalers, they're trying to figure out how, if they buy all these boxes and racks, they need to flip it around and get people to pay for whatever the hell they're run on these things, LLMs and otherwise. So
what? But I mean, I'm curious. I mean,
hey, what's up?
While we're in the dirt talking about this, I mean, we're literally at the lowest damn level you can get. Yeah. What are the use cases that they're talking about all of this advancement is going to solve for?
It's just now they've evolved the discussion from LLMs to MOEs, or these, model of experts, which are these, that's what GPT-4 is based on. You have all these little smaller LLMs that are quote unquote specialists, and they use these adversarial frameworks to get these things to argue with each other, as Jensen put it, and then pump out a better output. So what you're going to see, and the reason I think the rationale behind these new systems, the Blackwell, is to enable these larger these MOEs that are much larger, because they're multiple and maybe even redundant instances of LLMs, right? So,
I mean, at the end,
that's what they're talking about. So, it boils out to LLMs, and and then.
Yeah, but one of the use cases I heard, I mean, these are the ones I focused on, are in drug discovery.
Yeah,
and that's where you start getting into digital biology and mapping, molecules and in 3D level, the entire body on 3D level, and protein folding. That's where the large language models, I heard a pretty intense presentation by Kimberly Powell.
Yeah.
But I mean, she's saying to the earlier point, this is where to some extent the vision is a little, incomplete, because at the end of the day, the message is those things, the use case that NVIDIA provide is training model and executing inferences. That's what they do. Mm-hmm. You might have partners that do this, healthcare stuff. You might have partners that do that, but they position them as customers. So there's nothing really innovative in the higher level use cases. At the end of the day, those things train model faster with more parameters. Yeah. And when the model is trained, they run the model faster in a robot with a chip. This is what they do. It's an enablement technology. So this
how do you define innovation, right? Why doesn't anybody else have that enablement technology, Dimitri?
But they will over time. I think it's going to generalize. They will over time. There will be competition at this level, because at the end of this, these are giant calculators. I mean, we tend to overthink those things. I'm sorry, these are giant calculators. Now, I'm not saying this is not hard to do the new giant calculators. By the way, I was commenting to Leonard just a second, is that, one of the things that I find very interesting is that early in his speech, when he said that actually those chips have the ability to lower the precision where you're doing computation that is relevant to neural net that doesn't require the full. That's innovation at their level, which makes total sense. But at the higher level of the use cases, they're not doing anything from what I've seen.
Yeah, I think the transformer neural network, it is definitely an innovation. Again, I think that we've said this before on IoT Coffee Talk. That's actually, now that I think about it, because there was so much focus on ChatGPT, I don't think there was a lot of attention put into, okay, now how does a transformer neural network change the way that we can think about other applications. And, the innovations that NVIDIA is driving really tremendously, actually, with Blackwell, is just the incredible densification and capability of compute that these guys have been able to engineer into the systems that they just announced. That, undeniably, is going to just make all other AI computing and related computing and it just that much cheaper, that much faster, and people are going to have access to a tremendous amount of scale that no one's seen before. These things are realities. That's what these guys have done. Right?
Totally. Don't take me wrong. Yeah. There's a lot of innovation at this level, but what I'm saying that the use case is really at very strong enablement technology. And there will be at this level. They are leading for sure, but there will be competition at this level, because if the paradigm of those large language models really emerge as a significant technology used to build those higher level use cases, like Andreea mentioned, yes, there will be competition, there will be others, and they have a leading edge right now. No question about that. But again, my point is the use case is still it's the same thing when you refer to AlexNet, the first thing that discovered cats. Yeah. This technology was created in 1989. Now, we didn't have the compute, we didn't have the innovation, but there's nothing new in that crap. Okay. Now, doing it at scale and well is hard. That's where they innovate. That's what I'm saying.
And that's where NVIDIA has really been a catalyst for AI overall. And I think that, because, just to your point, man, the things that were imagined decades ago are now possible because the compute is possible. And maybe the favor that NVIDIA is doing is really pushing the envelope of what that cost also looks like, and so making it more accessible. But it's still supercomputing, right? Rob, you mentioned before what Steve Wozniak did with the first Apple is, how do I sit there and reduce a mini computer down into something that's personal size and can be consumer. Right. This is what he's doing, but at the supercomputer level, right?
And I think in this dimension, this is very interesting, because you probably heard me say that. I do believe that we don't necessarily need what we said, Turing complete machines to do AI. You need very specialized, hardware to build those models. And actually, this is in the culture of NVIDIA, because NVIDIA started, we forgot about that, but it started with graphic cards. Graphic cards was all about doing the videos, and you didn't need a general purpose computer to do video.
Coprocessor.
You needed the coprocessors that could do vectors extremely well and couldn't do recursive or whatever crap or interruptions. No, we needed to manage the video. So this culture of I'm building a purpose-built computer to do one of these tasks that is super important and very useful, I think that's the great direction for the industry, because we build those all general purpose machines and there's a lot of waste because they can do anything, so they do everything average instead of doing one thing very, very well. So I welcome this innovation, because this is really the right direction to have those components specialized, and then you orchestrate them. You put a CPU on top to orchestrate all those GPUs kind of stuff. So this is a great direction.
Yeah. So it's like the way I described it to Carl Freund, who I do a podcast with, on AI computing, is with CUDA, NVIDIA has general purpose application specific computing.
Well, you can generalize.
Or at least he took application specific hardware.
It's a very big hierarchy. It's a big hierarchy, so one level up, you're more general than one level down.
But then think about it. There's a lot of bloat and additional crap to virtualize and software define the stack, right? Which is what they've done to make it general purpose. But it's brilliant. it was also a huge gamble. He'll admit that, sure. And he says it quite often. It's like, we were so friggin' lucky.
Yeah. Absolutely. But he made it out of Denny's alive, and now he's changed the world. So there's that, So the other big news in AI yesterday was Mustafa Suleyman being hired by Microsoft to be their new CEO of AI and EVP. For those who don't know, he is He's the co-founder, he's the founder of DeepMind. When you talk about the transformer, and then obviously DeepMind pioneered all this stuff, and then they got acquired by Google. That's how Google started doing all their stuff. And if anybody's ever read Mustafa's book, it's called The Coming Wave. You should read it or listen to the audiobook. It's mind-boggling. And so to hear it right from the founder, from the guy who's created all this stuff, DeepMind is what an amazing deal. And so what a coup. It'll be interesting to know what the backstory is of why he's leaving Google and DeepMind to go to Microsoft and essentially OpenAI, right? You know, because you think his loyalty, or maybe he's seeing something he didn't like in Google. I don't know. Obviously, there's been a lot of weird news lately about Gemini and all the weird stuff it's producing when you ask it to create pictures of things. And so, you know, maybe things are going haywire inside Google. I don't know.
Yeah. Do you think that Google is not innovating fast enough these days?
I don't know. That's a good question. But there's a lot of weird news about this new Gemini thing and how it's giving some weird answers to questions and creating some strange pictures. And so, yeah, there's been a lot of buzz about some weirdness in Google lately. I don't know what it really is. But the fact that Google has lost him and he created DeepMind, and now, I mean, so that's a big deal for Satya being able to grab him.
Yeah.
You know?
Yeah. Well, you know, it could have been a lot of money too. So,
yeah.
But, you know, I mean, you know, the thing is, I think, Dimitri, I think you make a really good point, man. For the most part, a lot of the applications have already been imagined and maybe even codified in some way, just waiting for some compute to happen. They're not unknown. They were just cost prohibitive. But there were people who were doing it. And I guess we'll see whether or not that additional cost, you know, the improved economics and the compute power will make a difference for a lot of these use cases. So that's a really good point, man. But I don't think, you know, a lot of these things are a mystery. Like, you know, natural language processing, all this stuff. I mean, geez, how come people didn't get this excited about Project Debater? You know, IBM's Project Debater. That was pretty incredible, but nobody gave a crap about it. You know what I'm saying?
But don't forget that first big use case of GPUs was basically crypto mining. And the business model was there, right? For natural language processing, what the hell is the business model?
No. It's all kind of the same thing. Actually, you know, it's one of the really interesting things that, so number one, an analyst asked him, what about crypto? And he just goes, I don't think there's anything there. He goes, all right. And it was supposed to be the last question, right? It was supposed to be the last question. And he goes, let's have another question, because that answer was kind of short.
That's funny.
And then he went, yeah, oh no, it was hilarious. But, you know, the interesting thing was at the beginning, and we actually talked about this very early on in IoT Coffee Talk when all the nonsense started. He started talking about like token economy and how everything's going to become a token. I'm going, dude, you're like, it's like, so you're, you know, some of the underlying stuff here is kind of like blockchain-ish. You know what I'm saying?
Yeah.
And crypto-ish in a way, but
right.
Yeah, but that's a common misconception to actually tightly associate the blockchain technology and crypto. Because the blockchain technology has some obvious value because it's an immutable ledger. That's the value. The problem with crypto, and I've said that, I may not have said that on the show, but the problem with crypto is that the communism of software.
Yeah, no, actually, you're right.
Yeah, give me
an
example of a human
different.
Give me an example of a human construct that doesn't rely on central
you're right.
Especially for money. So I never bought into this crypto stuff because, I mean, who wants money not to be controlled by a central authority? And that's why I call it software communism. But the blockchain technology has a lot of value, and I do believe that tokenization probably makes sense, because if you think about it in the world of digital twins, tokens are basically the identity of the twins. So there is value of having a way to trace that in an immutable fashion. That I can buy. So the blockchain technology.
Well, yeah, no. But actually, I think a lot of what he's talking, what we're looking at with large language models, in particular, as a mechanism similar to the crypto token generating mechanisms, right? Tokens
and large language models are referring to words and groups of words.
But you're pushing it through an entire neural network to figure out what that next word should be, right? And so in a way that's kind of like similar to what you're doing with proof of work mechanisms, right?
So on another note, to give some love to Leonard, I spent several hours with Apple Vision Pro on my head. And
really?
I'm a believer. Yes.
Isn't it freaking nutty?
So yeah,
I saw that. So your review.
Yeah.
I don't not want an excuse to go to the Apple shop. Stop.
But before the Microsoft Googles, you mean?
No. What? Yeah.
What?
Oh, I remember HoloLens. Is that still around? Yeah.
Yeah. No, there's no comparison, man.
So before I came to Dallas, I went up to Tulsa, and a good friend of mine, we've done tech stuff together. I've known him forever. Anyway, he's a total Apple guy. He builds iPad apps and stuff. But anyway, he got one. And I sat down on the couch, and he had it on there, and he was like my guide for a multi-hour thing. He had me try all these different things, all the different types of apps, see the way musical entertainment happens, how movies happen, specific apps when you had, some of these videos are like when the little baby rhinoceroses are coming right up to you and you can pet them. When the butterfly lands on your finger. There was so much stuff that was just so, and you're turning all the way around and the world is still behind you and everywhere. We went through a lot of different things. We went, I had the giant aircraft engine blown up and it's running and everything, and we're taking it apart. The key thing is, you see what's happening there, but you also need to be able to, which a lot of people can't do, is see the possibilities in the future for this tech. And that was my takeaway. It's like, oh my God, when you think about a GE aircraft engine, it's like, and I'm like expanding it to the size of the entire living room I was in, and then taking it apart and then seeing the fluid dynamics. I was just like, it's mind boggling. And then the soccer games, the football stuff.
Yeah. Wasn't that cool?
Man, it's going to be Apple recording every football game, everything.
I'm telling you.
Because the experience, and my takeaway was, words and a person's description of it cannot convey what you'll actually see. You really, really have to experience it to believe it. Because when you tell something about it, they'll just go, oh, it's just a better screen, or it's just a better this. They don't realize this immersive in your face experience.
I was just thinking, I'm with you, man. It's like I actually look for excuses to put it on. It's like weird because it's really, and you know what? Here's the thing I noticed, Rob. Forget about the applications. It's the operating system itself, the environment it puts you in terms of like blending your actual surroundings with just these digital objects, and everything is so refined, right? And so, this comparison with the Quest 3, it's like, oh my God. Look, most people that are opining about this stuff, they never even tried the Vision Pro, or they did it for 30 minutes or whatever. You were actually coached through all the cool stuff that it does, right? The operating system is just incredible. And that's the starting point. When you go and you check out what they have with all the meta stuff, it's like a freaking toy. There's no comparison. But that's that one element I think people really underestimate is their operating system. The whole stack is so well done. That's going to be tough to emulate.
And you're right. That's what Apple brought to this that other players did not bring. They brought their whole ecosystem with them.
Oh yeah.
And so when you're right there, the first thing you see on your screen is like, oh, this is like what I'm used to seeing on my iPhone, my iPad. And so they brought their whole world with them in addition to the new stuff that looks familiar.
I think you said something that is very important, Leonard, that I believe people don't realize. And I haven't tried it yet, but I kind of imagine. But I think that the very fundamentals is that it's not a device that is trying to immerse you into a purely digital world, like a game or a movie, but it's a design that overlays the digital in the real world. And to me, that is the fundamental, really, really fundamental difference there.
But the one thing that I
described
is that the field of view is a little limited.
But that would be
the pass-through stuff. I thought is where they need to do the most work.
Yeah.
Everything else I thought was. I look for reasons to go. That shit'll never work. That shit's gonna work. It's going to work, and it's going to be used in some amazing applications. I mean, immediately I went to the medical field. It was things like that. But there's still some nuances associated with it. In terms of, for me, it was the pass-through stuff, because if you're wearing it and you're walking, you kind of have to make sure that latency is resolved. But
it will
super, be. It's super low as it is. Yeah.
Hey man, I've already watched guys drive cars wearing shit.
I know.
I love what Dimitri said. Dimitri, I really love what you said. I think that's a takeaway for me, because I haven't used it. I haven't tried it. I read a lot about it.
Andreea, we'll go meet at the Apple store here in Dallas.
Are you? You said you're around. How long are you?
I'm here till tomorrow afternoon, probably.
Okay.
And then I'm coming back.
You're coming back.
And I'm coming back in the first week of April.
Oh, I'm not here. Okay.
Anyway, go ahead. Sorry.
Yeah. No. I just wanted to. I think it's more for our audience.
Yeah.
Bring back what Dimitri said.
Yeah, I think it's really the fundamental is really to augment the physical world, to augment reality, and that's always been. I personally always been a believer, because if you want a broad use case, you have to deal with the reality we live in. So, and there's so many use cases where you actually want to have something digital on top. This is why, to some extent, I love the early version of the Google glasses, because you could see the world. You had this little thing on the top where you can have a look and check some things. So I always like that kind of, I want digital on top of my world. I don't want to go into a game. I get my big screen, I get my headset, and I'm in the virtual world, but I want to help in my world today. And there's.
Did you ever talk to anybody while they were wearing the Google glasses? That stuff bugged me the hell out. You're sitting there talking to them, and they're over here looking in the right. It's like,
that was a little weird. That was a little weird.
It's still weird. That shit still exists that way.
But I still, and maybe I have that with the Apple Vision Pro, but I still want this program where you go to a conference and you see the LinkedIn profile of the people popping up. This guy's done this, this guy's done that.
It's funny. Wow. Well, hey, they did announce here that they're going to be supporting Vision Pro in Omniverse. So
I saw that.
There you go. Yeah. So, and I think, from the looks of it and what I've heard, there's a lot of people that are really excited about it. So like the PTCs of the world, I'm sure.
Yeah.
Rick is going to go to Jim and say, hey, look, see what I told you? But, Jim's probably going to have to figure out a PTC support for the Vision Pro. To kind of,
but then
catch up.
Back to what I was saying, Leonard, because I have limited knowledge of the Omniverse, but does the Omniverse overlay on the real world? I mean, is it a model of the factory and it's an overlay on the factory? Because otherwise we're back to the old use case. It's a virtual, you get into the virtual world of Omniverse and you walk it through it. And for this, I don't think the Vision Pro is better than the HoloLens or whatever.
That's not what Omniverse. Yeah, Omniverse is like a simulation.
Yeah, so it's purely digital.
Framework.
So it's purely digital.
Yeah, I mean, it's like tooling. Digital.
Yeah,
it's kind of like a weird thing. I mean, they have a runtime. I forgot what it's called. It's separate. But I know that's getting too technical. Yeah, so in principle, yeah. But anyway.
Yeah, because my point is that if it's just a visualization this device for a virtual world, it's just another one. it doesn't leverage the true difference that they bring. At least it's my perception. I may be wrong, but
no. But if there's going to be an integration, I'm pretty sure it's going to be an MR enabled integration, right? It's going to be MR or mixed reality or spatial computing, type of thing. So, we'll see. We'll see actually, what I'll do is I'll get on the floor and I'll ask some questions about that.
Yeah, I'm actually going on Thursday, so I'm going to go have a look what they have.
Okay.
Have you seen a demo?
Yeah, you should ask the question too.
Have you seen a demo of the integration of the Vision Pro? Okay.
No, they just announced it, and I don't know. I have to just go and see if I can bump into it.
And what about the Jetsons? Did you hear anything about the Jetsons, which are focused for the edge computing?
Yeah, there was definitely mention of it, especially when they were talking about robotics.
Yeah,
a lot of mention about that. Not a lot of mention as it relates to like IoT-ish kind of stuff that we typically talk about on the show. But I think, when it comes to like edge applications, they're really looking at robotics, sort of like autonomous things, right? Their whole shtick is autonomy at the edge. And I think for the most part, what you're doing with IoT is you're just trying to gather the data, put the eyes and the ears out there. And I think he just assumes that those things are going to be there or on a robot.
Yeah.
And I don't know, his idea of a robot could very well be just a friggin' camera out there. It's that cyber physical integration. So
it looked like he was standing on stage with a bunch of robots.
Most of them not working.
Yeah.
Yeah.
Most of them not working.
They were hallucinating on the fly.
Yeah.
Like, come over here. It's like, I'm going to imagine that I won't do that.
Absolutely. All right. Well, I guess it's time to shut her down.
Yeah. Okay. Yeah. So who's going to take us out?
I think Bill is going to take us out.
Oh, yeah.
I've been absent for so long. Look, listen. We've got a number of subscribers. We've got a number of people that listen to us. I hear it all the time. I mean, we're walking around at shows and everything like that, and people are like, "Aren't you on IoT Coffee Talk?" And I'm like, "Yes." Not only yes, but hell yes. So everyone, tune in. We talk about all of this stuff in a real way. Not only do we trash it if it's trashy, but we praise it if it's proper. So join us again next week. Hit that like button and listen to IoT Coffee Talk. And remember, Elevate Our Kids is going to save education for those that are underserved and unserved. So go out there and get you a sweatshirt, a hoodie, a t-shirt, and all of that. Come on back and see us again next week. Peace.
Peace.